Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civey, and today we're going to discuss radiated and discharge sound in VAV boxes as well as diffuser sound. When you look at the catalog data for a VAV box, you'll see that it's broken into radiated sound and discharge sound. Radiated sound is the sound that comes from the casing of the box through the ceiling and into the space. Discharge sound is the sound that travels out the discharge of the box through the ductwork and into the space. So now let's draw a single duct box over a ceiling. It looks something like this. Put in an inlet, we'll put some ductwork going in and some ductwork going out of it. And then let's draw on the ceiling. Some of the sound will come through the casing of the box and radiate into the ceiling plenum. And from here it'll radiate into the space. The discharge sound just comes out of the discharge of the box and down the ductwork. The only thing that really is available to reduce the radiated sound going into the space is the ceiling tiles. They do a very good job at attenuating radiated sound though. Applications with open ceilings can be much louder than ones with ceilings because there's nothing to attenuate the radiated sound. In a fan box, radiated sound is a bigger issue than it is in a single duct box. So let's draw a fan box. That's our induced air inlet. Here's our ductwork going in, ductwork going out. Put a little control box on it, and there's our ceiling. So fan boxes have a motor-blower combination which creates sound in the box. This sound can travel out the induced air inlet and into the ceiling plenum. Then the radiated sound can pass through the ceiling plenum into the space. The discharge sound is before it comes out of the box, through the ductwork, and then into the space. Part of the challenge is that you have line of sight to the motor. You can actually look in the induced air inlet and often see the motor-blower combination. Let's make a little room here. So let's draw a little fan box here from the top. You can sometimes reduce the line of sight by putting in an attenuator. For instance, our TFS-F Phantom box has an attenuator that comes in this way, so you can't see into the motor. We put a right turn in it essentially. This reduces your line of sight and reduces the sound of the box. Now this can create an additional challenge where you create extra pressure on the box, which reduces your airflow, which means you have to turn your fan up, which means you've created more noise. Let's make a little more room again. Also, if you remember from the previous podcast on sound, fan box sound peaks in the second and third bands. These bands have sound waves that are 9 foot and 4.5 foot in length. Most attenuators are about 1.5 foot to maybe 3 foot long, so they're too short to really have an effect on the second and third bands. For this reason, it's best to use an attenuator designed for the fan box by the manufacturer so that you know the actual effect on performance. Like with the single duct box, the ceiling will attenuate a lot of the fan box radiated sound, but if you have an application that has no ceiling, be sure to select your boxes without a ceiling, because a ceiling can give you 16 to over 35 dB reduction, and if you're not going to have a ceiling, you'll want to know this when you do your sound calculations. You can do this in the team selection software. When installing VAV boxes, you should mount them as high as possible above the ceiling. If you're within a couple of inches of the ceiling, it won't give you the attenuation you expect. Another thing we often see is oversizing VAV boxes in hopes of making it quieter. This can actually have the reverse effect. By increasing the size of the VAV box, the damper will be closed more to maintain airflow. So let's say we have this box sized correctly. As the airflow comes in, because the damper is wide open or close to wide open at design, the air comes straight through the box. Now let's draw a bigger box. In this case, the damper is going to be closed off more and it'll force the air towards the casing, and this can add sound to the box. So now let's look at discharge sound. Let's draw our single duct box again and duct it out to a diffuser. Discharge air flows through the box, down the ductwork, and then out the diffuser into the space. Ductwork is usually lined, and lined ductwork is an excellent attenuator of discharge sound from the box. And diffusers usually have flex duct, which is also an excellent attenuator of VAV box sound coming down the ductwork. It can reduce the mid-frequencies by 20 dB or more. For this reason, discharge sound of VAV boxes is not usually a big concern. We do see a lot of unlined ductwork. If you have unlined ductwork, you need to be careful about discharge sound. Externally lined ductwork is not acoustically the same as internally lined ductwork because the sound doesn't see the liner, so it basically just bounces back and forth inside the ductwork and then escapes through the diffuser into the space. The attenuation values of ceiling tiles, lined ductwork, and many other common installation components are covered in the AHRI 885 standard. I'll do a future podcast on this standard that goes into a little more detail. I want to finish with a little bit about diffuser sound. Catalog diffuser sound is in test conditions, which are ideal and repeatable. They require 10 equivalent duct diameters of duct going into the diffuser. This pretty much never happens in the field, but this is what catalog data is based on. An ideal installation, you would have 3 duct diameters of hard duct going into the diffuser, and this will add about 1 NC to what you see in the catalog for sound data. Okay, let's scoot this over a little bit so I have more room. The next best condition is if you can get a soft bend of flex duct going into the top of the diffuser. This will be about 3 NC louder than catalog data. Now what we typically see is the flex duct laying across the ceiling and then just turned over into the neck of the diffuser. This installation would be about 5 NC louder than the catalog data. So even though flex duct is a great attenuator of sound coming from the VAV box, it can add to the sound of the diffuser if it's installed like this. The worst case is when there's too much flex duct used. It may kink or obstruct the inlet of the diffuser, which reduces the free area, increases the pressure drop, and increases the sound. An installation like this could add 7 to 9 NC over what the catalog data says. You can see that installation has a large effect on sound of VAV boxes and diffusers. So that's today's podcast on VAV boxes and diffuser sound. Thanks for taking the time out with us.